Welcome back. We're going to talk about the equation of a tangent line, the exciting stuff. Now, when you want to write the equation of a tangent line, we only need two things. One, we need a point, and we need the slope. We're going to write that down all year long. There's not going to be a single unit that goes by that we do not write the equation of a tangent line. So let's say I have this parabola here. What we want to do is we want to find the equation of this line. So what we need to do is, one, we need to know where this point is. And that's just going to be like the point 1, 1. We also need to know what the slope is. Well, the slope is just the derivative of our function at 1. And that's what this says. Our tangent line, you're going to recognize this one. We are going to use point-slope form. And that's it. Where x1, y1 is our point, and the slope is the value of our x coordinate. This is super easy to do, so let's take a look. Let f of x be the following function. We want to write the equation of this x squared plus 3x minus 1. We want to write the equation of the tangent line at 2, 9. Use the limit process. So the first thing we have to do, if I want to write the equation of a tangent line, I need a point. So what do I need? One, I need the point. Here they're lucky, we're going to give it to you at the beginning. Next, we need to know what the slope is at that point. So to get the slope, this comes from the derivative at 2. And to do that, I am going to use my definition. The limit as h goes to 0. And if we were to plug this in, using a rule from earlier, every h. This one's kind of nasty. X plus h squared plus 3 times x plus h minus 1 minus, remember the original function, x squared plus 3x minus 1. Remember, this is our f of x plus h, and that's just our f of x from our rule from earlier to get the definition of a derivative. All right, so that's where we got all that from. And again, this is all going to be over the letter h. When we expand it, we've already talked a lot about this. We know what x plus h squared is. That just becomes x squared plus 2xh plus h squared plus 3x plus 3h minus 1 minus x squared minus 3x plus 1 over h. Take your time on that one. Anything that does not have an h, will cancel out. They all cancel. And everything that is left will have an h with it. So that's going to give us the limit as h goes to 0. Go ahead and factor out that h. 2x plus h plus 3 over h. h's cancel. We let this go to 0, and we're left with a derivative of 2x plus 3. So there's my derivative right there. So as we saw in the last examples, once I know the derivative, now I can go find my slope. Well, that's just going to become 2 times 2 plus 3, which is 7. Now I'm going to write my line. To get my line, I'm going to use my point slope. Y minus y1 equals mx minus x1. So that's going to become y minus 9. My slope is 7. X minus x1, which is 2. Please leave your answer like this. Do not simplify. Just leave it alone. We're going to talk a lot about this. This is what, so this right here, if we were to graph this parabola, this is the equation of our tangent line, and that's huge for us. Now this has a lot of applications. For example, let's say I wanted to find out what f of 2.1 is. If I were to plug that in, this would become 2.1 squared plus 3 times 2.1 minus 1. And that is, ugly. I don't know what that is. I don't even want to try to figure out what it is. Well, a tangent line allows me to approximate. We'll talk more about this later on this year, but a tangent line basically says if here's my parabola and there's my tangent line at here's 2, here's 2.1. These values are actually pretty close together. So we can use our tangent line to approximate a value. We do this all the time in math. So if I want to approximate this value, I can now just plug it in. Let x be 2.9. I get y minus 9 equals 7 times 2.1 minus 2. Remember, my x is 2.1. I just plug it in. We get y minus 9 equals, this just becomes 0.7. So therefore, that is equal to 9.7. And that's our approximate value. So let's see how accurate it is. Okay? If I were to plug 2.1 into the equation, let's see how that is. 2.1 squared plus 3 times 2.1 minus 1. And notice we get 9.71. That's the exact value. We are pretty darn close. We're only off by 1/100th of a decimal. So that's a pretty accurate tool. The actual value, that was this f of 2.1, was 9.71. So if you notice, tangent lines actually offer a very good way to approximate a value for us. All right, question 6. Find the slope of the graph of this rational function at 3, 1. Okay. Then find the equation of the tangent line. So what do we need? Let's go and write it over here this time. We need a point, and they tell us 3, 1. Next, we need the slope, which is the derivative at 3. So what we have to do now is we have to find our derivative. Derivative, where are you? Derivative, derivative. Oh, there you're hiding. Hoi, I'm the derivative. You found me. I'm teasing. It's not that simple, right? So to get the derivative, we're going to use our limit process here. Whoa, what happened there? So let's go ahead and do this real fast. So we're going to take the derivative. F prime of x is the limit as x goes, not x, but h goes to 0. Remember, h is our change in our x values. When I plug this in, everywhere there's an x, I plug in an x plus h. So we're going to get 3 over x plus h minus the OG, 3 over x over h. Now we saw this before. This is our LCD method. We have to multiply both top and bottom by the LCD, which is x plus h and x. So I'm going to do that, x plus h and x plus h and x. And when we distribute, that's when the magic happens. We get the limit as h goes to 0. If I distribute, the x plus h's cancel, and I'm just left with 3 times x minus, here the x cancels, and I'm left with x plus h. All over h times x plus h times x. And what happens when we clean this up, we get the limit as h goes to 0, 3x minus 3x minus h over h times x plus h times x. These cancel, and I'm going to go ahead and write it down here. We get the limit as h goes to 0, negative h over h times x plus h times x. What happens to the h's? Oh heck, they cancel out. And if I let h go to 0, you can do this, we get negative 1 over, this becomes x times x, or x squared. And there's our derivative right there. Now we're not done, because we want to write our tangent line, so we got to find the slope there. So plugging it in, we get negative 1 over 3 squared, we get negative 1 over 9. Don't get lost in the algebra. But now my tangent line, we would go y minus 1 equals negative 1/9 x minus 3. And there is our tangent line for you guys. Very easy to do. Look how much fun that is. All right. Here's a really cool question, okay? Now, this is always a tricky one. We want to find the following. For the following, we want to find f of x. Notice not the derivative. Don't do any work on this one. We just want to know what the original function is. This is just telling me, the AP will sometimes ask a question like this just to see if you know what the definition is. Remember, in the definition, it is f of x plus h minus f of x. So if I want to find the original function, it's pretty darn easy. It's just going to be this x squared right there. So here, f of x equals x squared. Another way to look at it, like right here, look, it's x being squared. And that helps us for number 5. This is a tougher one. To get the function, well, the function's not 0, because notice there's no x in here like there was here. So what they're doing is they're replacing x. So remember, it's f of x plus h. So any way to get the function is really just look at this beginning right here, f of x. Ignore the plus h part. Well, what's my function here? It's sine. Now, this is sine of pi. But be careful, pi is not a variable. It's not x. So when I write this, I'm going to write the sine. All we did was we replaced x with pi. So that's just the sine of x. And there's a function right there. AP loves these type of questions. All right, I'll see you all later. You all have a great day. I'll see you soon. Smash that like button.